If you analyze how high-velocity software engineers, founders, and research teams build in 2026, you will notice a fundamental shift. The traditional single-prompt chatbot interaction is officially dead. Chatting back and forth with an LLM in a browser window, prompting, waiting, copying code, hitting a context limit, and starting over is a massive drain on productivity. The fundamental breakdown of legacy AI workflows comes down to two incompatible demands. Real-time live discovery. You need fresh, multi-source web indexing with verified citations and current documentation. Deep autonomous execution. You need massive reasoning depth, structured, long-form planning, and a massive context window capable of holding entire code bases, research papers, and execution logs without hallucinating. No single model handles both natively under a single interface. Web search LLMs often lack deep multi-step reasoning capabilities, while massive reasoning models lack live, sub-second web indexing capabilities. The solution in 2026 is a two-stage autonomous pipeline, Perplexity API as the live intelligence scout, paired with Claude Fable, 5 as the 1 million token execution engine. By decoupling discovery from execution, you eliminate manual research and build an end-to-end system where raw intent yields production-ready code, complete market reports, or automated systems without human intervention. The two-engine architecture. To understand why pairing Perplexity with Claude Fable 5 outperforms all other agentic frameworks, you have to look at how their respective capabilities balance each other out. Engine 1. Perplexity, the live intelligence scout. Perplexity operates as the frontline retrieval layer. When a project demands real-time data, such as breaking API documentation, financial updates, competitor releases, or multi-source web synthesis, Perplexity executes dozens of parallel web searches. It strips out noise, verifies citations, and aggregates raw data into a structured payload. Engine 2. Claude Fable 5, the 1 million token architect and self-checker. Claude Fable 5 receives the raw payload into its 1 million token context window. Fable 5 doesn't just generate text, it acts as an autonomous project lead. It ingests the complete context, formulates a multi-step execution plan, writes code, runs local tests, evaluates its own errors, and self-checks its output until the goal is fully satisfied. Step-by-step pipeline. Building an autonomous research-to-execution system requires establishing a clean API bridge between Perplexity's discovery layer and Fable 5's local agentic environment. 1. Deploy the Perplexity Discovery Scout. Phase 1. Real-time intelligence retrieval. Initiate a Perplexity API request using the sonar-deep-research endpoint. Pass your research topic or system requirements. Set the API parameter to return raw markdown along with full citation URL metadata arrays. 2. Inject ingestion payloads into Fable. 5. Phase 2. Context assembly and hydration. Pass the raw Perplexity Markdown payload directly into Claude Fable 5's context window alongside your local codebase, existing documentation, and system guidelines. Fable 5's 1 million token context buffer processes the entire dataset in a single prompt pass without information loss. 3. Generate the execution dependency graph. Phase 3. Autonomous task dependency mapping. Prompt Fable 5 to analyze the hydrated context and construct a structured JSON task graph. The model identifies prerequisite steps, API endpoints to build, test scripts to write, and edge cases to handle before writing a single line of code. 4. Trigger tool calls and code operations. Phase 4. Agentic code generation and local execution. Enable Fable 5's native tool use capabilities to create files, execute shell scripts, compile dependencies, and run local dev servers. Fable 5 actively writes files and runs tests inside your local sandbox environment. 5. Execute the autonomous evaluation gate. Phase 5. Self-correction and verification loop. If a test fails or an unexpected error occurs during execution, Fable 5 captures the terminal trace, analyzes the error against its 1 million context memory, rewrites the flawed module, and re-executes until all tests pass with zero human intervention. Why the 1 million token context changes saw everything? In legacy models, large context windows suffered from middle loss, where the AI forgot instructions buried in the middle of a long document. Claude Fable 5's context architecture processes as 1 million tokens with high recall accuracy across the entire window. This massive window transforms how you work with complex datasets. No more vector DB chunking. You don't need to build complex RAG pipelines or chunk documentation into tiny vector slices. You simply feed entire API reference manuals, full code bases, and deep Perplexity research logs directly into Fable 5 at once. Complete system visibility. Fable 5 sees how a change in file_a.ts impacts file_z.ts across thousands of lines of code without losing track of your original architectural requirements. Persistent verification. When Fable 5 runs a self-correction loop, it maintains the full execution trace, including previous failed attempts, terminal logs, and live search citations, preventing it from repeating past mistakes. Operational comparison. Legacy workflow versus autonomous 2026 engine. When you evaluate development output based on time spent, error rates, and manual intervention required, combining Perplexity and Claude Fable 5 completely outperforms traditional methods. Replacing a legacy manual chatbot workflow with a combined Perplexity and Claude Fable 5 pipeline transforms the development experience across every operational metric. While traditional setups rely on an approximately 128,000 token context window with lossy recall and static knowledge cutoffs, the modern pipeline delivers a massive 1 million token full-depth recall buffer, continuously updated through Perplexity's live real-time web indexing. Instead of manually copy-pasting code blocks and feeding terminal errors back into a chat interface, the integrated system executes direct tool calls, writes straight to the file system, and handles autonomous self-correction through automated retesting loops. Ultimately, this shift elevates the developer from a hands-on prompt operator and active builder to a high-level executive reviewer who oversees end-to-end execution. The key shift for 2026 is moving away from manual prompting and stepping into the role of a system architect. Spending your workday manually searching for documentation, copying code back and forth, and chasing syntax errors is an outdated way to operate. Your actionable next step today: set up a basic script that takes a Perplexity API research dump and feeds it into Claude Fable 5 with tool calling enabled for your current project. If you want to download the pre-built pipeline scripts, JSON task graph templates, and Agentic configuration files used in this architecture, check out the links in the description below. Don't forget to hit subscribe because in our next deep dive, we're building a fully automated multi-agent code refactoring suite. See you in the next video.